8.6 is the introduction to rational functions. I just want to get out of the way the vocabulary first. Alright, a rational expression. A rational expression is the ratio of two polynomial expressions. So when you look at the word rational, you see that the word ratio is in there, okay? And you know that expressions, okay, are an algebraic term that we have for any, it might have any expression that has like a variable, or it might just have a constant. So it gives you two examples here. It's just where a rational expression is where you're actually forming a ratio. A rational function is a function that's expressed as the ratio. So it's just where you have like y equals or f of x equals a rational expression. And then a new word is an asymptote, and we're going to look at an example of that in a minute. An asymptote is a line that a graph approaches more and more closely but will never actually reach. We'll show you that in a second. That goes along with rational expressions. And then something that we're going to have to learn is how to reduce rational expressions to lowest terms. It's the form of a fraction or rational expression where the numerator and denominator have no common factors except 1. You already kind of know how to do this. We're just going to apply it to rational expressions with variables. So what you used to think of before would be something along the lines of 4/6 reduces to 2/3 because 2 and 3 have no common factors except for 1. Sorry about that, my board is freaking out here. Okay, go ahead and pause it if you need to so you can get those vocabulary words down. Alright, we've got some parent functions here. I just wanted to do a little bit of a review. So we've got 3 that we've talked about so far in my class. We've talked about y equals the absolute value of x. We've got y equals x squared. And we've got y equals x. We've seen all of these, and we know that family of functions is formed by taking these parent functions and doing different things to them, doing different transformations, such as reflecting or translating. Or you might stretch, or you might shrink. And these are all that we've learned about so far. So we're going to talk about rational expressions and what its parent function looks like. The parent function is y equals 1 over x. And what I want to show you is the asymptote, is that it's that vocabulary, the word that we talked about before, where the graph will approach but never actually touch. So in this example, it's actually going to be the x and y axis. Okay, so if I kind of highlight, if you look along the y-axis, you can tell that these lines are going to get closer and closer, but they're never actually going to touch. So both the x and y-axis in this case are the asymptotes. And what we talked about before is how all of our parent functions are centered around 0, 0, and that is true also for this one. So in this case, our asymptotes intersect at 0, 0. So in a way, our function is still centered around 0, 0, even though it's not like the previous examples where they all have a vertex at 0 or where they cross through 0. It's still centered around 0, 0 in this example. And I just want to talk about exactly what this, how this function relates to the graph real quick. So as you can kind of see, let's look at like some various points here. We've got 1, 1 right here, which makes sense because y equals 1 over x. So if you put x equal to 1, so let's make a little chart. If I put x equal to 1, then y equals 1 over 1, which is just 1. Now if you think about x equal to 2, y is 1 over 2. I'm just getting that from my equation right here. Y is 1 over x. And that will give me 1/2, which is why I get this point right here. And when y is 3, it's going to be 1/3, which is this point right here. Which is why I say that this graph is approaching the x-axis. Because even if you think about a million, which I guess I can't really fit on my table here, just bear with me, then y is going to be 1 over 1 million. So it's just getting smaller and smaller and smaller as we go. It's never actually going to become 0 though. Alright, and why, the other thing I want you to think about is why does it not ever reach 0, 0? And that's because if you put in 0 for x, sorry about that, if you put in 0 for x, it's not going to work because you cannot divide by 0. So you can't do this. That's why it never touches that 0, 0 mark in the middle. Alright, so here's our parent function. Just a little side note there. And now we're going to talk about example A. So example A is a real-world situation with rational functions. And if I look over at our learning targets, I see that learning target 5 is to model real-world data with rational functions. So we're going to have to do some work with this. This is just an introduction, so don't worry if you're kind of still a little bit unsure about it. We're just going to keep practicing. So this one says that a salt solution is made from salt and water, and a bottle contains 1 liter of a 20% salt solution. This means the concentration of salt is 20% or 0.2 of the whole solution. So out of 1 liter, okay, so if I say my whole solution is 1 liter, then the amount of salt that I have is 0.2, and the concentration of salt that I have is also 0.2. And this is when we haven't added anything on there yet. We're going to show, this is part A right here. We're going to show what happens as we add more water to the bottle without adding any more salt. So let's say it says we want to talk about if it adds in half-liter amounts. So I'm going to add another half of a liter. That means that my whole solution is still 1.5 liters of water, but the amount of salt that I have is still only 0.2 liters. These are in liters right here. So the amount of salt is not changing. I'm just adding water. And so then to find the concentration of salt, I'm going to write this up here. To find the concentration, I'm just going to write concentration of salt. To actually figure out, it's kind of like a percent, to figure out what percent of the solution is water. I'm going to take the amount of salt divided by the whole solution. Okay. So to find the concentration of salt for this problem right here, I'm going to end up taking 0.2 divided by 1.5. Okay, it's like a percent. And that will get me, let's see, I did it over here, 0.133. And I'll show you one more. We've got 1 now because we're adding, basically we're adding 0.5 as we go. We're always adding 0.5 of this of water to the solution. So now we have added 1 whole liter. We've added 0.5 more. And our amount of salt is still 0.2. It's actually going to stay 0.2 the whole time. We're not going to change the amount of salt in our solution. And so now our whole solution is we started with 1 liter, and we put in 0.2 of salt, and now that we've added 1 liter of water, we're at 2 total liters. And I'm going to divide, once again, I'm going to take 0.2, and I'm going to divide it by 2. I'm going to take the salt divided by the whole, and that will give me 0.1.